the first design is called a completely randomized design. This is how it goes. You don't always have to have 3 treatments, but first, this is how you're going to do it. You're going to tell me who your subjects are. Then you're going to take those subjects and assign treatment, which means, going back to that caffeine experiment, we are going to assign, maybe half the class to this group, half the class to this group, and we have to randomly assign, and we have to describe how we do it. So maybe I flip a coin and send you to either group. I know I'm sending 15 per group, so as soon as a group fills up, I'll put the rest in the other group. Maybe I'll assign 30 numbers to a hat, and then the first 15 numbers I draw out are going to be treatment A, which would be my control group, and then the next ones would be my treatment group. Any way you're doing this, you must be specific so that if someone else reads it, that's a replication of those 3 key elements of experimental design. If someone else reads it, they should be able to repeat exactly what you did and be able to randomize their groups. So your treatment group, you have a control group, one group you're testing against always, and then once you're done, you compare your results. So here's an example we did as a class. 60 AP stat students, I randomly assigned 30 to 4th period and 30 to 5th period. I picked from a hat. The first 30 numbers I drew went to the 4th, and the second went to 5th. And then I was giving them snacks, I guess was my treatment. So 4th got no snacks, 5th got snacks. So 4th was my control group. 5th got snacks. I was trying to see who did better. So I compared the average class grade to see which class scores is higher. I thought the cookie was going to help. So the grade is my response variable. Giving them a cookie is my explanatory variable, and there you go. So that's completely randomized. Blocking is this next page. It's almost the same as completely randomized, but if something else might affect my scores, I would want to block first. So first you tell me your subjects, then you block into groups that are segregated. Block 1, everyone in block 1 should be similar to each other. Everyone in block 2 should be similar to each other, but block 1 and block 2 should be different. And then within each block, you run a little experiment. My example in class was the tennis rackets. So I took my experienced players, put them here, took my new players, put them here, and then I compared old versus new tennis rackets to see who served better. Here I compared old versus new tennis rackets to see who served better. And I was going to see if new rackets helped my serve speed. I didn't want an old and a new mixed, because if an experienced player served and a new guy served, it didn't really matter which racket they're going to get. The experienced player is going to do better. So I needed to block them apart. This is controlling for lurking variables. Randomization controls for other lurking variables, and I do need to randomly assign and say how I randomly assigned, otherwise I'll miss a question. But yeah, so that's blocking. And matched pairs, it looks a lot like the blocking. Really, I did a straight line diagram, but you take your subjects, you pair your subjects together. You want them like each other. This is another way to control for lurking variables. You want them like each other, and then you get one member of the pair gets one treatment, the other member of the pair gets another treatment. You must randomly assign treatment, so coin flip it. If you get heads, you get the treatment A. If you get tails, you get treatment B. Then you compare within the pair. And you do this for every single pair. If you do that, then there are ways later in the year we'll look at what to do with your findings, but you can compare person A versus person B and actually get a really good idea of if the treatment helps or not. The other thing you can do for matched pairs is you may compare you versus you, meaning you compare a subject against themselves. So a pre-test versus a post-test. If I was doing the tennis experiment, it's actually better to do with matched pairs if I do it myself. Who better to compare against than yourself? Me with an old racket versus me with a new racket. That's pretty easy to tell if I served better. I could do that for every member of the tennis team and look at their differences, and I really would be able to see who did better. So that's the end of this one, folks. I'll talk to you again soon with experiments.